In this video, we're going to talk about Macaulay and modified convexity. For this example, we have a couple of bonds, but in general, we're going to talk about the formulas for how you calculate these two quantities. So let's say we have a portfolio that has two zero-coupon bonds. One of them matures in 10 years for the given value. The other one matures in 20 years for the other value. If we have an annual effective yield of 6%, we're going to calculate both the modified and the Macaulay convexities. Now, an interesting note, when we say duration without a modifier, we typically mean Macaulay duration by convention. And if we want modified duration, we state modified duration. For convexity, it's the opposite. If we just say convexity, by convention we mean modified convexity. And if we want Macaulay convexity, we'll state it. All right. Definition of modified convexity is the second derivative of the price with respect to the annual effective interest rate over the price at that interest rate. So let's do the computations here. The price, of course, is the present value of each of the two bonds. When we take the second derivative, of course, we would bring the negative 10 and then decrease it by 1 to get a negative 11 for the first derivative. We'd bring the negative 11 down for the second derivative, so your negatives would cancel. So we've got 10 times 11 times the 895, 42, 1 plus I to the negative 12, and a similar computation for the second bond. So if we take our modified convexity then, we take the second derivative evaluated at 0.06 for the I over the price evaluated at 0.06, again for the I. And if we calculate that, we'll get 235.85. So looking at a general formula for the modified convexity, when we take the second derivative with respect to I, remember V is 1 over 1 plus I. So really you've got a 1 plus I to the negative t that you're differentiating. So each time when you take the derivative, the exponent really goes up in some sense. It's a more negative exponent. So the first one would be t, the next one would be t plus 1, and then the v exponent would be t plus 2. And then, of course, on bottom, we just have the calculation of the price. For Macaulay convexity, it's much like what we did for Macaulay duration. Remember, Macaulay duration, we weighted the times and calculated a weighted average. In this case, we're going to weight the square of the times and then calculate the weighted average. So the formula for Macaulay convexity looks a lot like the formula for the Macaulay duration, just we're going to square the times rather than just multiply by t to the first power. So here's the computation for calculating the Macaulay convexity. And in this case, if you simplify those computations, you'll get 250. And in general, if you go through the algebra, you can get the modified convexity by taking the Macaulay convexity, adding the Macaulay duration, and then dividing by 1 plus I squared.